past 21 months, the builders of the new California Department of Transportation, or Caltrans headquarters in downtown Los Angeles, have been lifting, welding, pouring, installing, testing, sweating, and swearing.
Port number 2, right here.
In an effort to make this massive 750,000 square foot office building a reality. Much of the innovative design of the building is evident from the outside. But inside, hidden behind walls and above dropped ceilings, is a labyrinth of pipes and wires connecting every area of the building and making office life possible.
In the industry, we say that heating and cooling is a luxury, but plumbing is essential.
The Scott Company is the plumbing contractor on this project. Its technicians are working on the guts of the building, the veins and arteries that will finally bring this structure to life.
Without water and drainage, society doesn't exist as we know it. The disease, everything that's been pestilence on man has, since the beginning of time, basically been traced 90% of it back to sanitation. Without sanitation, you have no cities.
The Scott Company is responsible for installing the plumbing system. Pipes, sinks, toilets, faucets, and pumps. Edward Mahoney is the general foreman. He's here to make sure no one's sitting back taking it easy. If anyone is, this job could spiral out of control.
Basically, plumbing system consists of two components. The pressurized water system delivering water to your fixtures, and the drainage system which takes the wastewater away. In installing a plumbing system in a building this size, we install the risers going from floor to floor.
Risers are the vertical pipes that move supply water up and wastewater down throughout the building.
In the case of multiple bathrooms, we prefabricate whole batteries of toilets, urinals, whatever, particularly if they're repetitive multiple times. We bring out a package with the waste and the water already assembled and attached to the risers. This makes it fast and efficient, and then hook it up, test it, have it inspected, and it's done. That's it.
This is going to be a bathroom upon completion. We have the wall that's open with all the pipes in it now. We have the 2-inch water line here that will be furnishing the water to the water closets, toilets, and sinks. And this is the hot water line that will be furnishing hot water to the sinks. And then eventually there'll be a toilet setting right here. That's the waste in the floor for the toilet.
The Scott Company is installing 700 toilets and urinals and 450 faucets. It's also running 50 miles of pipe, ranging from half-inch faucet supply lines to massive 12-inch storm drain lines. The plumbing engineer has to take into consideration many factors when designing a plumbing system. He starts by looking at the number of fixtures required by the building plans. Next, he determines how much water demand it takes to feed all the fixtures in gallons per minute.
Without pressure, the water doesn't flow. The water flows totally under pressure to get it from one place to the other.
In all tall buildings, the city water pressure alone isn't enough to push it to upper floors.
Our supply is from the city. On this particular building, we go up 7 floors on city pressure, and for the upper 8th through 13th floor, it requires a pumping system.
Here we have the house pumps. These are pumps appear to be very small, but they do a very good job for the water servicing the whole entire building, all floors, all your lavatories, sinks, drinking fountains, your kitchen area. All the water that enters the building all goes through these pumps.
Each of these pumps is capable of moving about 50 gallons of water per minute. And this building will need that kind of volume.
A large building like the Caltrans building, for example, might use 15 million gallons of water a year. It would equate to filling a large NFL football stadium up to the stands with water.
That is a lot of bathroom breaks. But 15 million gallons is half of what a building this size could consume. Low-flow toilets and automatic faucets will help keep the state of California from flushing resources down the drain.
What's special about these is that they have sensors so that when you wash your hands, you take your hand away and the water stops running. It's going to save considerable in the long run.
In semi-arid Los Angeles, water conservation is a primary concern for the designers of the Caltrans project. This and other structures being built throughout the world are leaning more and more towards sustainable or green construction.
Our energy crisis in the United States, for a lot of countries around the world, is a water crisis. And green buildings offer a tremendous amount of attention towards water savings.
Making the biggest splash yet in the world of water conservation will be the 54-story One Bryant Park building going up in New York City. Designers hope it will be the biggest, greenest skyscraper ever constructed. Developed by the Durst Organization and designed by Cook plus Fox architects, the building will use what's known as a gray water system.
The site is 2 acres in area, and each year, on average, 4 feet of water fall on this site. We're going to capture all of it, and we're going to use it to flush the toilets and for cooling tower makeup. And we're going to treat it before we use it.
The captured rainwater will be used in the toilets, but not in the urinals. The urinals won't use any water at all.
A waterless urinal looks just like any other urinal, except there's no flush valve on it. And it has a cartridge that is filled with a liquid that is lighter than urine. So when one urinates into the urinal, the water flows down the sides like any other urinal and actually flows under the liquid. It's a blue-colored liquid, harmless to the environment, flows under this liquid and right down the trap, down into the sewer system. And that liquid maintains the barrier between the sewer system and your nose.
One day we just sat down and did the math, and at 2 million square feet, if you look at the population and look at the number of times a urinal is typically flushed, it ends up being about 3 million gallons a year of water, potable water saved.
Although the urinals at the Caltrans building aren't waterless, they only use 1 gallon per flush. Most home toilets use 3.5 gallons per use. It's estimated the 2,000 occupants of the Caltrans building will flush 10,000 gallons of water a day.
There goes green means go.
The plumbing contractor is working to keep things flowing. But something doesn't quite smell right. And it's not coming from the sewer connect. The people working for the Scott Company are about to be hit with some really bad news. The development of the skyscraper is the story of technologies coalescing at just the right time to send structures soaring skyward. Technologies including indoor plumbing.
Public water supply is one of these great technological accomplishments of the 19th century. Without these water supply systems, you could not have the concentrations of population that you have in the cities and in those little cities that are skyscrapers.
Indoor plumbing in the U.S. actually predates the birth of the skyscraper. In 1829, the Tremont House in Boston became the first hotel in America with indoor plumbing.
This was considered an enormous luxury at that moment. But of course, once indoor plumbing was incorporated, it became a standard. And when we see plumbing coming indoors at the Tremont, we see plumbing coming indoors to stay.
By the time the first skyscrapers were constructed in the late 1880s, indoor plumbing had already become a common fixture of city life. But plumbing in a skyscraper presented unique challenges for engineers.
The story of plumbing in skyscrapers is really the story of the development of pumps. Pumps that were powerful enough to push water higher and higher in buildings that grew taller and taller.
With the help of pumps, designers found they could more efficiently control water demand and pressure by filling holding tanks at the tops of their buildings and letting gravity do the work. But the early office bathrooms weren't for everybody.
The early skyscrapers had single bathrooms at the core, and people walked down the hall to use the bathroom on every floor. Sometimes there was a men's room on one floor and a women's room on another floor. Sometimes in the early skyscrapers there were just men's rooms because there weren't very many women in office buildings.
Fortunately, the Caltrans building will have both men's and women's rooms. The Scott Company is outfitting 52 bathrooms with all the necessary items. But rumors have been swirling around the site.
A couple months into the job, found out that there's going to be some financial hardships. There was a crunch for money.
Worse than a crunch. The Scott Company, in business since 1906, became unable to pay its bills. Suppliers stopped providing equipment. That meant trouble for Clark Construction, the general contractor. The Scott Company handled not only the plumbing, but also the heating and air conditioning systems.
It impacted their performance dramatically. They were unable to keep up with the schedule here on this project.
But the schedule wasn't the only thing impacted by the cash flow problems. When union payments fell delinquent, a number of workers had to leave the job.
Worked for about 2 months, and company started to go belly up, and because we're organized through a union, we had to walk off the job. You know, for a lot of guys, it got real tough and real hard. Some guys like myself, I almost lost my house.
The trouble started in 2002, when the Scott Company worked on a Las Vegas super hotel, and the hotel skipped out on its bill.
A lot of the money, from what I understand, was being tied up on other jobs. They were owed a lot of money.
Reportedly, millions. The Scott Company started running out of materials, time, and personnel.
Why isn't he working? He should be started over there.
He needs more manpower.
The truth comes out. He needs more. Why doesn't he get...
Once the rumors got out, naturally, a lot of people start looking for other avenues for steady employment. When you lose key personnel, it's hard to recover.
This floor looks clean. The only good thing about it, it's clean, but there's no work going on, right?
Clark Construction stepped in to try to retain crucial people. Clark even paid suppliers directly, just to keep the job going. But Clark couldn't keep the Scott Company going. After a century of service, the Scott Company was forced to close its doors. Fortunately for the project, Clark Construction was insured for events like this.
And we'll be able to get to that shortly.
The build team chose Western Air as the replacement plumbing contractor. And the transition went smoothly. Western Air even hired many former Scott employees who knew the project, including Ed, plumbing foreman, Steve, general foreman, and Joe, piping superintendent.
I'm going to finish this job up. Western Air has talked to me a little bit about staying on with them, and like I say, they seem to be a very, very good company, and I will probably stay on with them if the occasion arises.
As Clark struggles to keep everything on schedule, they're hoping there are no more shocking surprises, especially since the electricians are in next to get this building wired. Plug it in, flip a switch, light it up, turn it on, and crank it up. Electricity keeps our big buildings running. We don't think much about it because the entire infrastructure is hidden behind walls. But in the Caltrans building in Los Angeles, the simple task of turning on a light takes giant transformers, breakers, distribution panels, conduit, miles of wire, and plenty of patience. Broken down, it's somewhat similar to the electrical system in your house. At home, power travels from the panel board to the outlet through the hot wire. When you're using a power tool, such as a drill, electricity flows through the hot wire, powering the drill, then back to the panel board via the neutral wire to complete the circuit. The ground wire is there to provide a safe path for electricity to follow in the event of a short circuit, which might result from a loose hot wire in the drill. The electrical system of this building follows the same basic rules, but on a much bigger scale. It starts 4 stories below ground in the electrical vault.
The vault is owned by the Department of Water and Power. The contractor actually built the vault for us to our specifications, but it's our equipment, our facility, and we're responsible for it. So only the Department of Water and Power has access to the vault for safety reasons and also because it's our equipment.
Chris Logie with the Los Angeles DWP is in charge of setting up the vault. It's the first step toward getting this building turned on.
We're installing the equipment, the transformers, the fuse cabinets, and we're just starting from scratch. It's certainly my biggest project to date. This is a big job.
The fun begins as the first truckload of equipment arrives at the site.
Today we unloaded 2 transformers. The transformers are very heavy, about 25,000 pounds, the larger one.
There are also tons of ancillary equipment. Once set up, only the DWP has keys to the vault, meaning no one working in the building has access. That's because there's going to be a lot of juice running through this room.
There's pipes that are running underground, and they're all over the city, and they're bringing in a very high voltage cable. It's 34,500 volts. That voltage is brought in, and it's brought into these large transformers. And what the transformers do, imagine the word transformer, it transforms that high voltage of 34,000 volts into something that people can actually use, 480 volts.
With every electrical system, especially one this massive, there are safeties built into the system. This system has multiple safeties, including breakers and fuses.
Each transformer has got a fuse cabinet. You might be able to see them behind me. They're about 11 feet tall, giant fuse cabinets. At home, the circuit breaker panel, they're there to protect the wire in your home from overheating. You happen to put too many pieces of equipment on, like a toaster and a microwave. The fuses in this room are here to protect the transformers. If there's too much of current drawn, before the equipment can be damaged, the fuse blows.
We have a couple of guys up here installing this 4-aught wire. The idea behind that is electricity will follow the path of least resistance. What we use it for is a safety measure, so that in case something goes wrong, the electricity will follow this to ground, which we have it hooked to. They have it hooked to a ground system under the floor. It's just like to where you have it in your home, except probably it's only one strand of this.
3 weeks into the project, the DWP electricians have made great progress. But the general contractor is pressuring them to move even faster.
They projected to be a 3-month job, but I understand the contractor, the customer would like it done in 6 weeks. So.
Okay, 1, 2, 3.
The vault is only the first stop on this electric highway. Dynalectric is the electrical contractor on the project. Their electricians take over where the DWP workers leave off. installing the rest of the equipment, conduit, wiring, and lighting.
Well, we're out of the vault. Now we're in the main electrical room that the vault feeds. This is one of our switch gears. In layman's terms, this is kind of like a big breaker box. It has several different breakers, and each breaker has a different function. One might be turning on the air conditioning equipment, one might be turning on the elevators, and so on and so forth. This is just one breaker right here. That's practically the size of a washing machine as compared to the size that you're used to turn on and off with your fingers in your house.
From here, electricity travels up to electric rooms on each floor.
We're on the 7th floor. This is the south end, the electric room. So from downstairs where the main electric room is, we have some of this bus duct risers, which is large pieces of copper busing that come up through the building, carries a lot of power, more than wire could. And we stick a switch here to grab onto it. It's got a circuit breaker, big wire, and what that does is it feeds this transformer, which will take it down to a voltage that's more usable in the building. From there, it goes to the distribution board. From here, it goes up, it goes down, and it happens to also feed these 3 branch circuit panels on the 7th floor, which from here go out to all the office space to feed their receptacles and their lights and plug their computers in.
Wires transport the juice from the panel board to the receptacles. Electricians run metal-clad or rigid metal conduit to protect the wires from getting damaged in the process of installation, or being nicked by a rogue nail driven into the wall to support a picture frame. To get the wires into the conduit, the electrician inserts a flexible wire tool. When it reaches the other end, it's connected to the electrical wires and pulled back through the conduit. Each one of these 50,000 electrical wires has an exact place it needs to go. That's why they need a good roadmap.
How about electric kit? Where is this fed from? Can you start looking at Amos where these things are fed from?
With 6 months to go before the first scheduled move-in date, the subcontractors are feeling more pressure than ever to get this building switched on.
Hey, it works.
And there's one man in particular applying the pressure. Clive Sondy, the general contractor.
So how long is it going to take to finish this? Here's the plumber doing the work. How long, Sonny boy? Tomorrow you'll be done.
Oh, hopefully.
Yeah.
Hopefully.
Okay, good.
Okay.
You're all right. I don't care what they call it.
The 85 electricians at the new Caltrans building in Los Angeles are busy installing the transformers, running conduit, and pulling wire. They're also hooking up 6,000 fluorescent lighting units. The modular design makes each one a snap to install in just a few minutes. Proper lighting has always been essential to productivity. Until the early part of the 20th century, lighting, natural lighting, influenced the very design of the building itself.
Workspaces were lit principally by daylight, so that the close proximity to windows was extremely important for the quality of space.
At the turn of the 20th century, Chicago architects designed central courtyards that allowed light into the center of the structure. In New York, architects designed tall, slender towers. A Appearing in both cities were buildings with indentations for better access to light.
It was the incandescent electric bulb, Edison, 1879, that changed everything. And it was during the 1880s that electric lighting began to come into use on a commercial basis.
Edison didn't actually invent the light bulb. He invented a less expensive, longer lasting, and more reliable light bulb. He also patented switches, outlets, and sockets to support his light.
Thomas Edison realized the light bulb needed electricity, and there was not any power generating plants at that time. So while he had a great invention, there was nothing to plug it into.
On September 4th, 1882, Edison's Pearl Street plant opened in Lower Manhattan, becoming the country's first commercial electrical generating station. Built in the heart of New York's financial district, the plant initially provided electricity for lighting to 59 customers in a 1 square mile area. Just 2 decades later, large buildings throughout the country were using electricity to run lights and elevators. The early electric lights were more for task lighting than room illumination. But the shape of things started to change with the introduction of fluorescent lighting in the late 1930s.
After the invention of fluorescent light, the internal space of the office could be much deeper than it was before because fluorescent lights are cool. So you didn't need to have any longer the light wells that cut into the space.
While the electrical engineering company on the Caltrans project isn't facing the same challenges Edison faced, the obstacles are still daunting. Today, owners aren't satisfied with electrical systems that merely function. They also want them to be efficient. No one wants to get shocked by an electric bill. It's estimated that 1/3 of all the energy used in the U.S. is consumed by large buildings.
Our aim is to try to reduce the amount of energy that it takes to support the building.
Arup, the electrical engineer, working with the architect, has come up with some bright ideas to help conserve power in the Caltrans building.
We do that by designing a more efficient mechanical system by using light fixtures which produce less heat, so there's less cooling.
Each light fixture has a motion detector, so it only turns on when it's needed. The sun also helps light the building.
The south side has photovoltaic cells, so they produce energy. If you use half of the amount of energy, you have to spend half the amount of money every year. And if with big buildings, those are several $100,000 of savings every year.
The One Bryant Park building in Manhattan will have another cool way of saving money. Because electricity rates fluctuate throughout the day and night, power is more expensive during peak demand, usually midday. The One Bryant Park building will maximize its electricity usage through a system called off-peak cooling.
In Manhattan, we stress out the electrical infrastructure on very hot days in the middle of summer all at the same time. And it's just incredibly inefficient. So one of the unique technologies that's happening here is called ice storage. In the middle of the night, when there's very little stress on the infrastructure, we're going to use chillers to make ice all night long, like a chipmunk storing nuts for the lean times. And then in the peak of the day, we actually have cold stored up.
Inside each large tank are dozens of spiral tubes, stacked on top of each other. The tanks are also filled with water. At night, coolant from the chillers is pumped through the tubes, freezing the water solid in the container. During the day, warm coolant is pumped back through the tubes, drawing cold from the ice and chilling the coolant. The chilled coolant then goes to air handling units to cool the air. Although off-peak cooling is already being used in many buildings throughout the world, the One Bryant Park building is several years from completion. The Caltrans building, on the other hand, is in the final stretch. Everyone is racing toward the finish line, and people are starting to sweat.
We got a lot of work in here. When you get a date out of these guys, I want to finish this crap. I want to get done.
It's been 22 months since excavation began. Clark Construction, the general contractor, is struggling to get the building finished.
Schedule is very important. We have a contract to deliver this project to the owner, and you have a set date. They expect to move into this building.
That date is August 13th, 2004, less than 4 months away. To add to the pressure, Clark faces penalties of $25,000 for every day it's late.
Great.
Over the past 21 months, Clark has faced rain delays, a distraught man hijacking their tower crane, mock-up testing trouble.
We got some water here. We got to find out where it's coming from.
Elevator ropes jumping off their shiv. And the bankruptcy of the project's plumbing contractor. While every job experiences road bumps, it's Clive Sondy's job to make sure no pothole turns into a bottomless pit.
Clive is the on-site superintendent. He's the one that's making sure that everybody's meeting their deadlines.
They must need a C&I dog or something. The ones upstairs are not done.
Clive is what you might call a motivator.
I don't know why this can't be done. Is there any reason this can't be done? Can you kick them in the ass and get them done? Well, you got to plan ahead and always come up with almost goals that people can't meet. Why isn't it up in the air? What the hell are we waiting for? Shoot for the moon, and if you get real close, you're in good shape.
He is very, very direct. He tends to be to the point.
Well, if there's no freaking problem, why isn't this done?
Which is good, because you don't want to beat around the bush.
They don't belong here. Just throw the out. Look at all that duck. All right. Just throw it out.
I'll talk to John with
and charge him for it.
But he's pretty much a general out there.
I'm tired of babysitting. I'm not a babysitter.
Personality-wise, it's kind of like Lombardi. You hate him, but you respect him. And if a person in his position isn't constantly, I hate to say it, hated, then he'll probably get walked all over. I think he's doing a fantastic job.
In many ways, Clive is like a stern father, making sure his kids are getting their chores done. He's also looking out for their well-being.
You got safety glasses?
Yes, sir.
Okay. And that ladder say that you can't go on the last 2 steps? Almost every ladder I've ever seen, you're close to a shaft. I'd hate to see you go down. How you doing there, Sparky?
Pretty good.
When I'm building a rocket ship, it's mostly common sense and experience and knowing what things are supposed to look like. He's an old steel man. You guys should get along good.
Yeah.
Like any other business, you're only as good as the people you have. You got to treat them well. You got to train them well. And if you lead properly, they'll follow you.
In June 2004, Clive Sondy was diagnosed with cancer and had to leave the project abruptly. He underwent surgery 3 weeks later to remove a portion of his pancreas. Clive is currently recovering from the major surgery. With 2 months to go before the first move-in date, it's an all-out sprint to the finish line. Inside, the new Caltrans District 7 headquarters building is starting to look like an office. Because the Caltrans employees will be moving into the building in waves over several months, some floors are farther ahead than others. Eventually, 2,000 people will occupy this building. And this is the man who's going to hook them up. Dave Pilkington of Contra Costa Electric is in charge of installing the phone and data backbone of the building.
We start after the blueprints are made, and they figure out how many phones they want, how many data locations they want. And then we come in and we start roughing in the cable, which is pulling the cable in. We pulled in 1.5 million feet of data cabling. We also pulled in about 20,000 feet of voice riser cabling. We keep track of all the wires by a really, really good labeling schematic. Everything is labeled. You can't forget any labels. You really can't.
While the cable is being roughed in, technicians on the second floor are outfitting the central computer and phone rooms with servers and voice equipment.
This here is the voice MDF, main distribution frame. Basically what happens here is SBC, the phone company, will bring in lines from the street and they will hand them off to us, the building. They're going to bring in 3,600 lines.
The adjacent room holds the heart of the data network.
This is the data MDF, the data main distribution frame. What happens here is we've sent fiber optics throughout the whole building to all the IDFs, the independent distribution frames. We have 2,400 fiber lines. And what we're doing now is testing them to make sure they work. Every computer in this building will be talking through this room.
Fiber optics are long, thin strands of glass, which use light signals to transmit information. Technicians use fiber optic cable because it can carry far more information over longer distances and at a much faster speed than traditional copper wire.
2 of these fibers, because you need a transmit and a receive, 2 of these fibers could probably run this whole building if they wanted to be on one network. Every computer in this building.
But there will be dozens of departments with individual networks and servers. The fiber optic cable travels up conduit to independent distribution frames, or closets, on each floor, where copper wire then takes the information to each phone and data jack.
The most important aspect of my job is to have the customer come in, to plug in and have no problems at all with their data.
But that goal might be hard to meet with less than a week before the first move-in. While Dave's struggling to get everyone wired, a few select Caltrans employees are getting a sneak preview of their new digs.
Man, have you made progress?
Well, I love the space. I just love the way the lighting's working for it.
While the excitement is growing for Caltrans, the anxiety is building for those racing to get the structure finished in time. Brian Day, project director with the California Department of General Services, has been here at the site as a liaison between various groups, including Caltrans, the end user, and Clark Construction, the general contractor.
Have they changed? Have they increased, or are they staying constant?
This week is perhaps the most pressure-packed. We have people on site working 24/7. We have exactly 4 days left. We have 4 days left to complete the fire life safety testing.
Can't have that.
The Caltrans District 7 user group begins moving equipment and furniture over Friday, August 13th. And we anticipate meeting that date.
This is one of the final steps. If the state fire marshal sees anything not yet up to snuff, the Caltrans people can't move in at the end of this week. Considering the complexities of construction, it's amazing that a project stretching back 3 years could be mapped out so carefully that it might actually meet its completion deadline. Let's rewind a bit.
When you see the skin and you look at the real one and you realize it has holes in it and it builds up color.
I never come up with an idea and that's the project and hand it to you done. It's not the way I work. I see the creative process and architecture something much more evolutionary.
We actually started excavation on April 23rd of this year. To date, we've moved about 190,000 out of 200,000 cubic yards of dirt.
There's a few different ways to place concrete. Shotcrete is where it's actually blown onto the wall with high air pressure.
The most difficult job is the steel erection itself, is actually putting the structure up. And the guys that have the most difficult job is the raising gang along with the 2 connectors.
It's a big day for any construction site. This is why we usually have these parties.
These are chillers, which, if you were to think about it, are giant air conditioners. These are the strip window units we're installing out here. We have around 1,000 of these to put in.
Grab the number 1 right here, put number 2 right here, so I can get 1 and 2 in order here.
Without water and drainage, society doesn't exist.
We're on the 7th floor. This is the south end, the electric room.
Sure, we're connecting wires and we're connecting computers, but what we're really doing here is connecting people.
This project could have easily taken a 6-year envelope. We've basically cut that time envelope in half, from an existing asphalt parking lot to a 1.2 million square foot structure. Is truly an outstanding effort.
The Caltrans building was a fast-track project. To save time, construction began before many details were hammered out. This took the coordinated efforts of the architect, the general contractor, the subcontractors, the state, various engineers, and consultants. From a construction standpoint, the fast-track method proved successful on this project. But the real critics have yet to weigh in. The people taking over this building in just a few days.
One set of employee elevators.
I love this building. This is going to be great. The interior space is fantastic for the employees. We get lots of natural light all through all the workspaces, which is very important.
This is my first time being inside of the building, and I must say it's fantastic. And I know that employees will definitely enjoy working here.
As we've watched the building under construction, just from across the street, the anticipation has grown over time. It started with a big hole in the ground and it slowly worked itself up. It'll feel vibrant and like part of Los Angeles, unlike we felt before.
Thousands of independent events have transpired to form a building. And like all large building projects before it, this one too takes its place in the skyline and in the fabric of the city itself. The planners, designers, and builders of this project are already looking ahead to their next undertaking, where they'll face new challenges in the race to build the next monument.